Aromaticity. Today we have studied aromaticity. Aromaticity is the chemical property of the compound. The properties of the aromaticity. This is the property of the aromaticity. They are highly stable and they can undergo reaction. Now we can study the Hukel rule. Hukel rule determines the compound is to be aromatic. So what is Hukel rule? The compound must be planar. For Hukel rule, compound must be planar. The compound must be conjugated. The electrons must be delocalized. And it must follow 4n plus 2 pi electrons, where n is equal to 0, 1, 2, 3. So for a compound to be aromatic, the compound must be planar, the compound must be conjugated, the electron must be delocalized, and the number of electron present is 4n plus 2, where n can be 0, 1, 2, 3. To any type of any number can be present. If n is equal to 0, then there will be number of presence of electron is 2 pi electron. So total number of electron there would be 2 pi electron. So such example of this type of 2 pi electron system. So now we can see the 2 pi electron system. This is a 2 pi electron system. Here one double bond is present. One double bond gives 2 pi electron. So here total number of electron is 2 pi electron. This is planar, and there is also presence of delocalization of electron. So by resonance it can gives different types of structure. So this compound is aromatic. If these conditions are followed, then the compound should be aromatic. So it is a 2 pi electron system. If n is equal to 1, then 4n plus 2 pi electron, then there will be number of total electron is 6 pi electron. So for a compound to be aromatic, the most common example for a 6 pi electron is benzene. So this is aromatic. Now we study the anti-aromatic properties. So for a compound to be anti-aromatic, the main difference between aromatic and anti-aromatic, this is also planar conjugated. For anti-aromatic, the compound also planar conjugated, but only difference between aromatic and anti-aromatic is there is presence of 4n pi electron, and for aromatic there is presence of 4n plus 2 pi electron is present. So for a 4n pi electron system, here n can also here n not can be 0. If it is 0, then total number of electron will be 0. So n can be 1, 2, 3, 2. But here n can be 0, 1, 2, 3, 2. So for an anti-aromatic system, here if the 4 pi electron system, like if this type of system is present, here one pi bond gives 2 electron. So here presence of number of pi bond is presence of 2. So total number of electron is presence of 4 pi electron is present. So this is anti-aromatic. Double A means anti-aromatic. But if there is this type of structure is present, but here total number of electron is 6. because there is presence of lone pair, because this lone pair also involves in resonance, and so there is total number of electron is 6 pi electron. 2 double bond is present, 2 pi bond is present. For this reason 4 pi electron is present, and the lone pair of nitrogen is also involved in resonance, so total number of electron is there is 6 pi. But in boron there is no lone pair is present, so only 2 double bond is there, and in contribution there is only 2 double bond is calculated. For this reason this is 4 pi electron system, and this is 6 pi electron system. Now we can come non-aromatic system. What is non-aromatic system? Non-aromatic system is not planar. Like if there is this type of, there is total 4 number of pi bond is present, so total pi electron is 4 into 2, 8 pi electron is present. But we can assume that it must be anti-aromatic system, but not. It is exception, and non-aromatic system this is. How this is can be a non-aromatic system? Because this cannot be, this is not planar, because this is the steric hindrance, and due to the size of the ring, because it is highly strained ring, because this has high steric hindrance, so this molecule cannot exist in our nature like this form. This molecule cannot be present in our nature like this form. This molecule, whenever in laboratory or in nature this compound is formed, this compound goes, or in our body this is also a carcinogen type of compound, but if this form, this goes to tub shape compound, because this compound cannot exist in this form, because this is highly strained compound, so this is tub shaped compound. In nature, in our universe, this is tub shaped compound, so this is not planar, so this compound is known as non-aromatic. But also if but is there any possibility to compound to be a aromatic? Is there can be possibility, but if there can be possibility like this type of system, this type of system cannot exist, this type of system cannot exist, but they can form aromatic system by bridgehead position. In this way they can exist, but not this way, they cannot be exist, but in this way they can be exist. So these are the types of non-aromatic compound, and if we consider the stability order of a aromatic, non-aromatic or anti-aromatic compound, then stability order is aromatic is first. Aromatic is most stable compound, then non-aromatic because it contains both aromatic or anti-aromatic property, but the only problem is that this is not planar, and then anti-aromatic. Anti-aromatic compound are highly unstable compound. So aromatic is most stable and this is least stable. So the lecture of aromaticity is stopped here. Thank you.